Hello viewers, welcome to another section of my tutorial, and I have a problem in AC theory, which is a topic in applied electricity. So it said a voltage given by V of t, which is equal to 230 sine 314 t, is applied to a series circuit, and the resulting current is I of t, which is equal to 10 sine 314 t minus 30 degrees. Find the resistance of the circuit, find the reactance of the circuit, then determine the power drawn by the circuit. So now, this is a simple scenario, and it's a question here from AC theory. So let's interpret the question and see how we go about it. So from here, we can see that we have the voltage source to be 230 sine 314 t, and this is a wave, or is a AC voltage, let me say, and this is the instantaneous voltage V of t. So this one we have I of t, but the current is lagging behind the voltage by a phase difference of 30 degrees. The lagging signifies the negative here. If it's positive, it's leading. Since it's negative, it's lagging. So now let's move straight, find our resistance and our reactance. So solution. So from here, what you are going to do is, we know that in a circuit or in an AC circuit, we have impedance. Impedance Z is equal to our Vm over our Im. So when you divide the total or the peak voltage over the peak current, you are getting the impedance. And impedance has two components, the resistance and the reactance. So first of all, we have to find the impedance, then we find the resistive component and the reactive component. Now from here, our Z, which is the impedance, will be equal to the Vm. That is the peak voltage is 230 here. You will bring 230 over the peak current, which is 10. And that will give me 23 as my impedance. And impedance has the symbol ohm. It's an opposition. So opposition in an AC circuit is called an impedance. So we have 23 ohm. So this is the impedance of the AC circuit. So the A part is saying you should find the resistive part of the circuit, or the resistance of the circuit. So now what you are going to do is that impedance has two components, and representing it with the phase difference, we are going to have our impedance Z here. Here will be 30 degrees, where we put our current. So this place represents our resistance R. This will represent our reactance. Let's make it K. So we can see that this is the impedance, but it has two components. And where is the phase difference? To find our R, that is the resistance R, is simply Z cos 30 degrees. And this will be equal to 23 cos 30 degrees. So what will be the answer for it? So 23 cos 30 will give us 19.92 ohms. Then also, let's find a B, which is the reactance of the circuit. So the reactance from the diagram you can see is the Y component, or the vertical component of this impedance Z, and that will give us Z sine 30 degrees, which will be 23 sine 30 degrees, and this is equal to 11.50 ohms. So this is the reactance. And finally, we've been asked to determine the power drawn by the circuit. In an AC circuit, if you are to find the power, just the power, it means they are requiring you to find the active power. And we know that the active power is simply equal to IV cos theta, where theta is the phase angle, and the whole cos theta here is what we call the power factor. So from here, all that we need is our I and our V. The I is the effective current and the V is the effective voltage. So from here, our I is equal to, that is Vm over root 2. To find Im, that is I current, Im over root 2. So this is equal to our 10 over root 2. And that will give us our I here, the effective current. That is the IRMS. Then our VRMS is simply Vm over root 2. And that will give us 230. From the question, they gave us 230 as a peak. So 230 over root 2. So our power becomes the 10 over root 2 multiplying 230 over root 2, then cos the angle given, which is 30 degrees. So this will give me 2300 over 2 cos 30, and this will be equal to 2300 over 2 will give us 1150. So 1150 cos 30 degrees. And what would that be? So if you have 1150 cos 30 degrees, that will give us 996. So we have 995.9 watts, which is also equal to 996 watts, since it's the active power. This is the end of my video. Thanks for watching. Kindly subscribe as I post similar videos on the AC theory.